Hey guys, welcome to another video of C programming. In this video we'll see different small interesting programs, floating point programs, and I hope you like it. This is the first program. In this program we've used a variable f in which we have stored a random value. This is a floating point value. In my last video I have explained how to declare variables and the different ways of printing variables. If you have integers, you need to use %d. If you have a floating value, you would use a %f. If you have a character, use %c. You want to print a string, use %s. So in this video we'll just see this very small program in which we are using %e, %f, %g and %lf for printing the same float value. So now why are we doing this, and what will the output be of this program? So let's just see the output first, and then I'll explain to you why this is happening. So the first output when we print %e is 4.300000 plus 001. This is because this is a scientific notation uh, value. As I have mentioned here in the comment, it is a scientific notation operator %e, and that is why we get this value, this exponential value over here. Now %f, it is generally used to print float values. Normally people use %f everywhere to print float values. It is very common to use %f. So as usual you use %f and the float value will be printed. Now %g is the shorter form of %e or %f. So it just prints one value after the decimal point. And %lf is the long double float, and it prints the same value just like the float. So if you have a value which is greater than which is longer than the normal value, so you can use this lf command and you can print the long double. So this is the first program. Let's quickly jump into the next program. Now here we have used two preprocessor commands, and we've used this math.h because we are using the size of function. Now what is the use of the size of function? Now before that, let's compile and see the output of this program. Now we get output as 4, 8 and 16. Now what are these outputs? These are actually the number of bytes that this value is taking. Now 3.14f means that it is taking the 3.14 float value, which is of 4 byte, and hence when we size off, it is printing the number of bytes which is being taken. Now size of 3.14 normal, it takes the integer value as 8 bytes, the double, and this, it varies from compiler to compiler. 3.14L is the long double. Some compilers, Turbo C, will give you 10, but in Dev C++, as we are using the Dev C++ IDE, it's giving you 16 over here. So it depends, it varies from compiler to compiler. Now let's go on and look at the next program. Now this is an interesting one. This is normally asked in interviews. Now when we print this number, we have declared a variable a and we've stored 0 0.7 in a. Now we've given a condition as if a is less than 0 0.7, it'll print less, else print more. But we have already assigned a equal to 0 0.7. So let us see what the compiler prints in this case. So it's printing less. Now let's just see what happens in case of 0.8. Now when I assign the variable a as 0.8, it's again a floating point number, but this time it will print more. Now why is this? Now this explanation we'll see in the next program over here. This is because, let's see the output, you'll immediately understand. In this program I've just rounded off the values of zero point 0.7 and 0.8 as stored in this compiler. So in this program, as you can see, zero point 0.7 is rounded off to 0.699999881, and 0.8 is rounded off to 0.8000119. So this particular value, when we print in this program, it considers it rounds off. When it is 0.7 over here, it will round off it to 0.6999981, and when we consider 0.8, it will round off to 0.8000119. So that is why with the same program you have two different outputs when you change two different numbers. So the 0.7 example is generally asked in interviews. I hope this video helped you out, and thank you for watching.